Welcome to Yatim Khana and Madrasa Anjuman Khairul Islam's Pune College of Art, Science and Commerce. Myself, Dr. Arif Tamboli, working as Associate Professor in the Department of Electronic Science. Today we are going to study the next topic in the Unit 1. In the last lecture, I have explained you about the syllabus of SYBSc Paper 1, which is called as Communication Electronics. So in Unit 1, in the last lecture, we have completed Introduction to Communication Means and Modes. And we have also completed electromagnetic spectrum as well as brief idea of frequency allocation for radio communication. And radio communication we have divided into two categories. One is called frequency modulation communication and another is called amplitude modulation communication. So a specific slot of the frequency is allotted for this communication, and that also we have completed in the previous lecture. Today our target is to study the block diagram of electronic communication system. So let us proceed for that. The block diagram of electronic communication system. So whenever you want to communicate or whenever you want to pass the information from one source to another source or from one location to another location. So one location you may call as an information source where the information is available. Another location you may call as a destination. So you may require some electronic circuits to pass the information from one location to another location, and that various electronic circuits are included in the block diagram of electronic communication system. So if you just look at this block diagram of the electronic communication system, you will understand that first block is information source, second block is input transducer, third block is transmitter, fourth block is channel, means it is called as communication channel. So we are going to study all blocks in detail. Next, fifth block is called receiver. So there are radio receivers, various types. So it is a receiver. Then next block is called output transducer. And last block is called destination. So source to destination, this is the flow. But in between, you can observe that this particular portion, which is called noise. So noise is introduced into the communication channel. So noise enters into the communication channel, whatever the communication channel it is there, which we are going to study in detail. So we just cannot stop the noise, but we can minimize the noise. So now let us proceed one by one. We'll understand each block in detail. So in this way, this is a general block diagram of electronic communication system. Now there is one more block diagram, but from that the idea is not clear, but at least you will come to know that what is the source of information. Means source of information consists of what type of information. So it may consist the information in the form of speech of a human being or speech of the any other persons. Then it may consist pictures, it may consist word, it may consist code, it may consist symbol, commands, data, or your video. And in this way you can say that the source of information will have such a type of information. Now in this block diagram there is no block introduced which is called transducer. So that is what I said here. So this is a general another block diagram, and at the last you come to the destination. So what is the destination? Destination is the last point where the radio, TV, computer, telephone, so like that, this is the another block diagram. So we'll focus on this block diagram only. So these are the various blocks which are there. So we'll go one by one. So first block we'll study what is the information source. So first block is our information source. So for understanding, I have again taken all that blocks over here. The electronic communication system contains the following blocks. Number one, source of information signal. Number two, input transducer. Number three, transmitter. Now there we have just shown the block as a transmitter, but this transmitter block consists various small electronic circuits, and the names of that small electronic circuits are: number one, modulator circuit; number two, amplifier circuit; number third, frequency filter; number four, antenna. So like that, these are the four different circuits which are present inside the transmitter block. Then 4 is called communication channel. Then fifth is noise. Here I have taken because noise is introduced in communication channel only. Then sixth block is your receiver. So it is called radio receivers like that. Then number 7 is called output transducer, and last is your destination. Now again, if you come to the receiver, look at the receiver. So in the receiver again there are various small circuits like transmitter and receiver. These are the very important blocks. So in receiver you want to collect the information. So in receiver small electronic circuits are antenna, frequency filter, demodulator circuit and amplifier circuit. So if you just look at the 4 blocks present in transmitter and 4 blocks present in receiver, you will find out amplifier is a common. So here also there is amplifier in the transmitter, and in the receiver also there is amplifier. You will find out in transmitter again there is a frequency filter. You will find out in receiver again there is a frequency filter. You will find that antenna is again there in transmitter and antenna is again there in the receiver. So this is the receiver's block. And there is a one circuit which is present in transmitter which is called modulator, but in case of receiver it is a demodulator. So modulation and demodulation are opposite processes. So in this way here, these blocks are very simple. One more thing you note over here, in transmitter, last block is antenna, but in receiver, first block is antenna. So in this way you will understand from the next blocks which we are going to study one after other. Now these are the 8 blocks of our electronic communication system. So let us go in detail one by one. So the source of information signal. So this is our first block. So what is the source of information signal? The source of information signal is basically a low frequency signal which is to be transmitted from source to destination. So first of all, you try to understand the source of information signal is a low frequency signal and its amplitude is also low. Information signal is also called as modulating signal or baseband signal. So the information signal, another name is called as modulating signal or baseband signal. So there are 3 names. One you may called as a information signal, another you may called as a modulating signal, and third one you called as a baseband signal. So here this is a general idea about the information signal. Now what are the examples of information signal? Example of information signal is voice signal of a human, or it may be video signal, or it may be a picture, or it may be a text. So these are the 4 examples of information signal. It is a low frequency signal and its amplitude is also low. In analog signal, a continuous wave normally denoted by a sine wave and may vary in signal strength, that is called amplitude or frequency time. So in analog signal, a sine wave is taken as one of the example of the analog signal. Okay, not necessary that sine wave is only the example of analog signal. I am going to give another examples of analog signal also after this slide. Next, a digital signal is described as using binary 0 and 1. So all of you know that digital is a logic 1 and 1. Digital talks only about high voltage level and low voltage level and no in between that. Now the example of analog signal. So analog signals example is your human being's voice signal. So if you look at the electrical characteristics of that human being's voice signal, so it will somewhat look like that. So as I told you that analog signal means not only a sine wave, because sine wave is a very smart waveform going in positive half cycle, going in negative half cycle. But if you catch your sound signal with the help of a microphone, you will not get a very smart sine wave, you will get the signal somewhat like this. So this is one of the example of the analog signal, voice signal of a human being. Next example which I have taken for this analog signal is, you can measure the blood pressure of a human being, and the blood pressure of a human being you can see here at various times at different mood, when he or she is cooking or when she is working, the BP is continuously changing. So this is the variation in the blood pressure. So variation in the blood pressure is itself also an analog signal, which we convert into electric signal. We'll see that later on. Third example which I have taken is your ECG. So to check the what pumping of the heart, we normally take the what ECG. So ECG is also the one of the example of what analog signal. So in this way, these are the three examples which I have taken of the analog signal, but not necessary. You can say that a video recording done by the video camera. So scene is nothing but an analog signal. So which you are recording, or you are taking a picture. So picture is nothing but analog signal. With the help of camera, if you take a picture, picture is also nothing but the analog signal. So these are the examples of analog signal, and that is called your information signal. Now, after this, that block means first block, your information source. So this is the information signal. So this goes to what? Input transducer. So now next block is called your input transducer. So what is that input transducer? We'll see. So transducer is basically used to convert any signal, that may be a sound signal of a human being, that may be a scene that is your recorded to be recorded, that may be a picture. So transducer is basically used to convert non-electrical signal into electric signal. Transducer is basically used to convert a non-electric signal into electric signal. The sound of a human being, that is called voice frequency. So sound signal is about variation in the pressure. So variation pressure in the pressure is about non-electrical signal. So to convert that non-electrical signal into electric signal, you need microphone, which you call normally as a mic. So microphone converts sound waves into an electrical signal. So that is a transducer. So this transducer. So you can say that transducer converts non-electrical signal into electric signal. So another example of transducer which we have taken over here is your video recorder, or you can say camera. So now you want to shoot the scene. So some acting is going on and you want to shoot the scene. So what is the device which you are using to shoot the scene? So that is nothing but your video camera. So here video camera or video recorder, you can say that, is nothing but a transducer. So that scene is recorded in the form of electrical signal. So these are the two examples which I have taken as a input transducer. So here it is very simple. It is given, it converts information into an electrical signal. For example, microphone converts sound waves into electric signal. Video recording camera converts video signal into an electric signal, and accordingly. Now next block is your transmitter. So this is a very important block, because now information has to be transmitted from one location to another location. So depends on the distance between two locations, the logic is used for transmitting. So in case of some transmitters, modulation is not done. But for a long distance transmission, modulation is must. So I have included all blocks in that, whether the transmitter is used for transmitting the information over a small distance, or whether the transmitter is used for transmitting the information over a long distance. So here, first of all, the output of the second block. What is our second block? Just we studied the second block we studied, that is your input transducer. So from transducer, what is the output? Electrical signal. So that will come to the transmitter. So in the transmitter, in the first block of the transmitter, there is a one circuit which is called modulation circuit or modulator circuit. So first of all, that electrical signal is taken in the transmitter and it is modulated. So modulation is required if and only if the signal is to be transmitted over a long distance, say 100 kilometer or more than 100 kilometer. And otherwise, modulation is not required. You can go for a baseband communication. So next block is, after modulation, amplifier is used. So signal strength is weak, it is amplified. Then next block is frequency filter. So unwanted frequencies are removed. Only the frequencies which we want, means the information signal should be very clear. That's why frequency filters are used. And now, as I told you, if you want to transmit the information with the help of electromagnetic waves, then you use the antenna to convert that electrical signal into electromagnetic waves, and then that electromagnetic waves will get propagate in free space with the speed of light. And these are the four blocks in case of a transmitter. So first block in transmitter is a modulation circuit, second block is amplifier, third block is a frequency filter, and last block is antenna. Antenna is required if you want to transmit the information by using electromagnetic waves. So antenna converts an electrical signal into electromagnetic waves, and converse is also true. Antenna also converts electromagnetic waves into an electric signal. So in the receiving end, you will observe this antenna at the first location, because first of all we have to catch the electromagnetic waves. So let us proceed for the next block. So here I have given the detailed information of each block. Transmitter consists of modulation circuit, amplifier, frequency filter, antenna. Proper modulation circuit is used. Now what kind of modulation you want to do? Analog modulation or digital modulation? So I have quoted the example of analog modulation. Say suppose amplitude modulation, frequency modulation, or phase modulation. So proper modulation circuit is to be used. Amplifier is used to increase the strength of the signal. Frequency filters are used to remove the unwanted signal. In case of wireless communication, an antenna is used to convert the electric signal, that is information signal, into an electromagnetic waves. The signal is modulated for long distance transmission, means the signal is modulated for long distance communication only. So these are the four blocks information about the transmitter. Now after transmitter, what comes? Communication channel. So in communication channel, here after transmitter, communication channel comes. So here first block, second block, third block, and then it comes to communication channel. So communication channels are three types which are widely used. So that we'll study now one by one. So let us go to the communication channel. So communication channel. So there are three types of communication channels used widely. Number one, metallic cables or copper, or made by the copper or aluminum. So all of you know that electric signal is normally carried with the help of metal. So metallic cables are used. So I have shown here various types of the metallic cables which are used as a signal carrier. Metallic cables can be made by the copper or aluminum. So this is the one communication channel. Next communication channel, as we discussed earlier, free space, air. So in free space, what is transmitted? Electromagnetic waves are transmitted. See here, electromagnetic waves. But here, if you want to use the free space, and if you want to carry the information signal by converting electric signal into an electromagnetic waves, you will require transmitting antenna. And on other side, you will require receiving antenna. Rx means receiving, Tx means transmitting. So transmitting antenna and receiving antenna are required. This distance may be hundreds of kilometer or few kilometer. So in this way, when another communication channel which is your free space, but in free space you can only transmit the electromagnetic waves and it propagates with the speed of light in free space. So that is a second communication channel. And third communication channel, which is widely used nowadays also because of its speed, that is the fiber optic cable. And in fiber optic cable, such a type of cables you might have been observed at various locations in networking or very close to the your internet cafes and like that. So here this is the fiber optic cable. So fiber optic cable is also one of the communication channel, but only the important point to be noted in this case, in case of fiber optic communication, fiber cable carries the information only in the form of light signal. In case of fiber optic cable, fiber cable carries the information only in the form of light signal. Therefore, you will require electric to light converter and light to electric converter. So a particular wavelength. So in this way, that care has to be taken, and this is the third communication channel. Then after third communication channel, Here I have introduced noise. So noise is always there link with the communication channel. So let us see the description. It's very simple. Noise is unwanted electrical or electromagnetic energy that degrades the quality of a signal in communication process. So when the noise is linked with the information signal, the quality of the information signal degrades or decreases. Noise enters noise enters into information signal at the coupling points when wherever there are the joints. It also links with the metallic communication channel. So metal is more immune to the noise, you can say. It can be minimized. Noise can be minimized. So noise is basically unwanted electrical or electromagnetic energy. So in short, noise is unwanted electrical or electromagnetic energy. It degrades the quality of what our information signal. Now basically the noise are classified into two types. One is called internal noise and another is called external noise. So what is internal noise? Internal noise is nothing but suppose you are using communication channel with the help of copper material, and due to the heating of the copper, because you pass electrical signal and heating process take place. So heating of the component means heating of the cable takes place. So that is called your internal noise. Then short noise. Sometimes short circuit is there. So that is the short noise. Partition noise. Partition noise normally takes place. It is internal. Partition noise normally takes place in case of semiconductor component. You know very well in FY you studied NPN transistor and PNP transistor. So in NPN and PNP transistor, always we say that the addition of base current and collector current is equal to emitter current. Means emitter current IE is equal to IC plus IB. But remember, actually IC plus IB is equal to IE, which we have written the equation is by considering conventional direction of flow of current. Actually, current flows from emitter to base and then emitter to collector. So whenever an electron jumps from emitter and enters into the base, they get divided into two parts. Some of them, some electron go to the base section and some go to collector section, and this is called partition. So electron divided into two different parts, some of them going to the base and some of them going to collector. So that is a partition noise. So this partition noise takes place normally in case of semiconductors. Then low frequency flickering noise. So this is also one of the noise with which you are familiar. Suppose you are watching the TV and most of the time you observe that your TV screen is flickering. Why we say TV screen is flickering? Because you can notice with your naked eye that screen is appearing 4 times or 5 times in 1 second. You can notice with your naked eye that the screen is appearing 4 times or 5 times in 1 second, that you called as a flickering. And if the same screen appears more than 25 times in 1 second, if the same screen appears more than 25 times in 1 second, then it is said that screen is not flickering, because you cannot notice or your eyes cannot notice that high rate of change of one frame. So if the entire frame of the television, that is the screen, changes with the rate of 25 frames per second, then you say that there is no flickering. So flickering happens with a low frequency. So this is a low frequency. So I have written here monitor or TV vertical scanning frequency if less than 25 hertz. So vertical scanning means repeating of the whole screen. That is called your vertical scanning frequency. So this is the about internal noise. Now let us go to the another part of the noise, which is called external noise. So external noise is what? It is atmospheric, it is a lightning, it is industry, and it is a solar noise. So there are four examples of external noise. It is atmospheric, it is lightning, industrial, and solar noise. So atmospheric noise, all of you know very well. In due to the industry, in the atmosphere only, there is so many signals are propagating, and when you are here in the classroom, you cannot listen the radio station, because you require a radio to convert that radio frequencies into a audible frequency. So that in the atmosphere already there are so many types of communications are going on, and electromagnetic waves are there. So that is atmospheric. Lightning. So lightning normally occurs in the rainy season, and due to the lightning, you know very well that you cannot watch a particular TV channels or like that. So when the lightning is going on, so there is a disturbance in TV channels. Industrial noise. In industrial noise, whenever you talk about industry, there are so many electrical motors which are running, single phase motor, three phase motor, and there are so many cables which are carrying very large amount of current, and they produces the noise. And the last one is the solar noise. So in this way, the noise is always there. We just cannot stop the entering the noise, only we can minimize it. And therefore there is one topic which we are going to study: signal to noise ratio. Signal to noise ratio. So strength of the signal should be very large and strength of the noise should be very less but natural. So noise occurs in digital and analog system both. So if you say that I have a digital signal only in logic 1 and 0, there will be no noise. It is not like that. Noise occurs in digital and analog system both. But analog system are less tolerant to noise. But analog systems are less tolerant to noise. Their digital signal, it is a then digital signal are more tolerant to noise. So digital signals are more tolerant to noise. So analog signals are less tolerant to noise. So something like that. Now here I have shown you the examples of lightning, then electric spark and short circuit of the battery. So these are the examples of external noise. So external noise, lightning. So this is the lightning, then this is a short circuit, spark, and this is again a battery short circuit. So like that here. So most of the time when we are watching the TV and when we receive a mobile call and when we go to the very close to the TV, you'll feel that our mobile communication also gets disturbed. So that is because of the noise only. Okay, now after the communication channel in which the noise is enter, we'll come to the next block which is called receiver. So receiver is the next block. So once again go to the basic block diagram. So after completing the communication channels 3, we enter into the what? Noise. Okay, and then after noise, then I am coming to the receiver block. So receiver block and transmitter blocks are important. So like that here. Now in receiver block, let us see first of all what comes: antenna. In transmitter, last antenna is there, but in receiver block, first of all the antenna will come into picture. So see here. So in receiver, first of all antenna will come into picture, because if you want to catch the information which is already present in the free space in the form of an electromagnetic signal, then you require antenna, because antenna will convert electromagnetic signal into an electric energy. So you will catch the electromagnetic signal of particular frequency for which the antenna is particularly designed. Then that electric energy converted by the antenna converts electromagnetic energy into electric energy. That electric energy is given to the frequency filter, because unwanted frequencies to be removed. So only information signal frequency we are interested. So frequency filter is there, then amplifier is used, and then proper demodulation circuit is used. And after proper demodulation circuit, we will get our original information back over here. So here let us see the description. So receiver consists: first block is antenna, second frequency filter, third amplifier, and fourth is demodulation circuit. Proper demodulation circuit used, because what kind of modulation technique is used on the transmitting end? At the receiving end, the demodulation circuit used accordingly. Means suppose at the transmitting end, amplitude modulation technique is used. Then at the receiving end, diode is used as demodulator in case of that particular amplitude modulation. So we have given the example. Proper demodulation circuit is used, such as diode as a demodulator in case of amplitude modulation. But suppose at the transmitting end, amplitude modulation technique is not used. At the transmitting end, suppose frequency modulation technique is used. Then in the receiving case, in the receiver, you must use Foster-Seeley detector circuit for frequency modulation. Foster-Seeley detector circuit for frequency modulation. And after that, means when you use the proper demodulation circuit, amplifier, it is as used there same role amplifier plays in both transmitter and receiver, increases the strength of the signal. Same role the frequency filters plays there in transmitter and receiver. Frequency filters are used to remove the unwanted signal. In case of wireless communication, antenna is used to convert an electromagnetic waves into electrical signal, that is your information signal. And our now next block is called output transducer. So now that electrical signal which is present at the output of demodulator. At the output of demodulator, our electrical signal means information signal is present. But now we must represent it or reproduce it with the help of output transducer. So output transducer, it converts the electrical signal into original information. For example, loudspeaker converts audio information into sound waves. For example, loudspeaker converts audio information into sound waves. Or suppose at the receiving end where we have recorded the scene with the help of camera, but now we want to observe that scene, we want to see that scene, then what we required? Will require CRT tube in television circuit, which will convert the video signal into image or picture, which will convert the video signal or picture. So in this way, here two examples I have given, and I will show you that here. See, this is your loudspeaker. So input of the loudspeaker is electrical signal, output of the loudspeaker is audio signal. And here is the monitor. Now at the recording time we use the video camera, but reproducing time we would need a monitor. So monitor will show us the recorded scene or recorded picture. So this is the this thing. And final block is called your destination, the location where the original information is collected. Computer or mobile phone or landline phone, or you can say that in front of this monitor you are sitting, you are the destination. If you are listening this particular output of this particular, you can say that loudspeaker, then you will be the example of the destination. So like that, this is the last block of the destination. And in this way you will observe that there are various blocks which are used in communication system, and with by combining all these blocks, we can say that an electronic communication system works or functions very systematically to transmit the information from one location to other location. And here in this communication channel, noise enters. We can minimize the noise. And in this way, I will declare that today's topic for block diagram of electronic communication system is over, and in the next lecture we'll proceed for the detailed study of the noise in communication system. So because of the noise there are so many problems created, so signal to noise ratio and other parameters of the noise that we are going to study in the next lecture. Thank you very much. Thank you for watching the video. See you in the next lecture.